Scientific notation. So we have two vocabulary words. The first is standard notation, and this is just the normal way of writing numbers. Okay, this is what you've been using forever. All right. If we want to write 1,000, it's 1 with three zeros behind it. Okay. If we want to write 0.001, right, 1,000th, tenths, hundredths, thousandths. Okay, same thing. It's just the number written out in the form that you're familiar with. Scientific notation is a little different. Okay, scientific notation is for writing really large or really small numbers, and it's a way to do it easier and in a shorter way than writing out all those zeros or all those numbers. Okay, so 1 million isn't that big, but we can turn it into scientific notation. We make it the product of two factors. So in this case, one of the factors is the 1. All right, and then the other factor is going to be 10 raised to a power. And that power is going to be however many zeros I have, right? I'm moving my decimal place from here, 1, 2, 3, 4, 5, 6, and it's going to be 1.0 times 10 to the 6th. Okay, and these are all equivalent. Written out in standard notation, 1 million, or written out like this. And you can see that writing this out for 1 million doesn't really save me any time. They're about the same. But when we get to very large numbers, like this one, this is 1 followed by 75 zeros. Okay. And it's called 1 quattuorvigintillion. All right. So you're probably not going to run into this kind of a number unless you're doing certain types of science, any type of astronomy, or things where you're working with really small, cells or atoms or quarks or something like that. They're going to use numbers this big or this small. But we don't have to go to this extreme to see that, after we get to maybe 1 billion or really small numbers where we have a lot of decimals, it's going to be a lot quicker and a lot easier to use scientific notation. Okay? And the one thing I want you to see is that this is 1 million. This is scientific notation for 1 million. This is scientific notation for 1 quattuorvigintillion. Okay? I had to write one extra number to make this number instead of this one. Okay? When you're working with really large numbers, this saves a ton of time. All right? It is a little hard to get your brain wrapped around it at first, but this is going to be way easier if you're working with those really large or really small numbers. Okay, so translating scientific notation into standard notation. If your exponent is positive, okay, and that's the exponent on your base of 10, your base is always going to be 10 because that's what moves your decimal places over. So if your exponent on that is positive, you're going to move your decimal point to the right. Okay? You can think of this as a balancing act. All right? If I have a really small number here, 3.24, but I'm multiplying it by a really large number, my number is going to be really large. So if I make this number larger, say I just go over 1 space, I would have 32.4 times 10 to the 4th, right? So now I've got a little bit larger number here and a little bit smaller number here. But multiplying them together, both of these numbers are still the same. With scientific notation, we always make sure that we have a number between 1 and 10 here. Okay, we have one single digit here that's not a 0. All right, that's standard, or that's the normal scientific notation form. Okay, so if we're turning this into standard notation, we're going to keep going, and we're going to basically take our 3.24 and move it over 1, 2, 3, 4, 5. Okay, 1. So we moved it over 1, 2, 3, 4, 5. And we can see that 324,000 is equivalent to 3.4 times 10 to the 5th. Okay? Now when we are working with negative exponents on our base of 10, it's going to move it the other way. So if we have 3.24, it's going to go to the left 3 places. 1, 2, 3, 0, 0. There's my decimal. And I can throw another 0 on the end. And these two numbers are equivalent, which would be tenths, hundredths, thousandths, 10 thousandths, 100 thousandths, 324 hundred thousandths.